Hey there, this is Tom Oden. This is my baby name generator using Markov chains. Let's give it a go. Let's run the code really quickly. So we'll show you user interface first, prompted for some basic parameters. So we'll say M for male names. We're looking for minimum length, we'll say 3. We're looking for a maximum length, we'll say 10. We're looking for a Markov order, we'll say 4, just for fun. And how many names should be generated? Let's grab 10 names. And we get some fairly normal names: Giovanni, Christian, Roland. Uh, these are ones I've kind of heard before, so I'd say those are fairly normal. We'll have another go with Markov. This is just like a quick way to generate them, and this is with an order of 3. Collop, Jet, or Maven. So if we decrease an order of a Markov order, we get some slightly more interesting names. Anyway, let's take a look at the code. For baby names, this Java file is basically user input to determine parameters that would be passed off into the actual generator, just basic input and output, and then prints the names that are received from Markov. Markov is definitely the meat and potatoes of the program. Once instance of Markov is created, a bunch of class variables pertaining to the user's input are made, and then we run through 3 main methods. We run through read, set probabilities, and add name to list. So for read, we generated permutations of possible substrings by iterating through the baby names text files, and for each n-order substring, if it's a Markov order of 2, we looked at every 2 sets of 2 characters consecutively and marked their occurrence along with their successor in a hash table of probability lists. It had an array list with each possible succeeding character, and we stored those characters in a letter probability class that had the letter, the counter of occurrences after a substring, and then eventually calculates probability later on. So once we had read the whole corpus through, we set the probabilities. And we set the probabilities by looking at each substring and its array list of successors, and then compared the count of all successors to each letter's count and converted those to actual probabilities of percentages. So then, in order to generate names, we start off with an empty substring, and we'd until we reached a terminating character, we'd add characters name. We'd add characters by rolling a random number, and then we'd iterate through the possible successors. We'd stop iterating when, as we go through each successor, we'd keep a running sum of the percentages for each character. And when that sum had exceeded the value of the random number, we picked the character whose value eclipsed the random number. So that made it a random choice, and then we'd move on to the next substring and keep generating that way. So we ended names just so you see how we began and ended names. When we read text in, we created a buffer on either side. I called it a bumper. So in the beginning, we put a bumper of underscores that was relative to the length of the Markov order. So for each n of the Markov order, we put a bumper on the beginning, and we also put one on the end as well, so that we'd know when to stop. And then we also could remove the bumper in the same fashion. Grab any underscores outstanding. So yeah, this was a fun project. It taught me to think a little bit differently about how names can be processed, and definitely helped me understand Markov a little bit better. Thanks for the opportunity to practice it.